Welcome to Weld.com. Today I have my paisan, Mr. Hamar Aguillo, with me, and we were talking and getting a little background and talking about skill sets and what each of us are kind of comfortable with, and
exactly.
And you said you were a little shy on the aluminum, hadn't done a whole lot of aluminum.
It's been 3 years, brother.
Been a while.
It's been a while since I welded aluminum. I welded aluminum on MIG, but with spool gun, but as far as aluminum on TIG, it's been about 3 years. So I'm trying to get that rust out of there. That's why I got you with me.
Well, I'll tell you what, I'll work you a trade. How about this? I'm a little weak on stainless, small bore stainless pipe.
Right.
So
I'll
help you out. I'll help you out with the aluminum. We'll kind of go through some stuff here and get you
stacking dimes.
Re-educated, get you tuned up, get your mojo back,
There you go.
and then you can kind of work with me on some stainless pipe there or something, some tube.
I got you, brother. I got you.
Been about 3-4 years ago, and you said the last time you remember welding aluminum, your tungsten gets into a ball immediately.
Correct.
So you were on what kind of machine?
A sinker wave. Another sinker wave.
Okay. So did you start out with a sharpened tungsten?
No, I kept it bald.
You kept it bald.
Yes, sir.
Okay. So there's ways that you can purposely ball it. The main thing is we're welding aluminum. We want to weld on alternating current.
Correct.
Because we have an oxide layer that we need to break through it a little bit. But yeah, we'll work up some stuff here. The main thing right now we need to talk about is we're going to run some beads. We've got a couple of joint configurations figured out for you here. So this all kind of looks the same. What's this over here? Is that aluminum?
You feel it? Some stainless, no?
You need to smell it, see what it is. That's stainless, isn't it?
Stainless.
It smells like stainless.
Stainless.
But it looks
like
visually,
aluminum.
I mean, you're just glancing at it, but as soon as you pick it up. So, these two kind of look essentially the same. You got the color and the shine and everything. Obviously a weight difference.
Oh, for sure.
But just glancing at this, you think, well, that's clean. So we'll talk about this, how to clean it up, how to set the machine and everything. So let's get some sleeves on, get a hood on, and we'll go to town.
Sounds good with me.
All right, my brother, I'm gonna set you up on an Everlast 210 EXT.
Nice,
and
brother, nice.
I'm gonna keep this real simple.
All right.
So that we'll talk about tungsten grinds and tungstens. We're gonna use 332nd E3 tungsten. Pure argon, about 15 cubic feet an hour. I believe we've got a number 7 cup on there, 7 or 8. We don't have a gas lens, so we're just keeping everything simple.
All right.
So the first thing we want to do is go through some menus here.
All right.
And I'm going to get back to the start of the sequence over here. I've got a pre-flow, and I don't want to have any time cycle in that. I have zero pre-flow. We have the starting amps at 5. Not critical with that.
Correct.
So I'm going to do 100 amps.
All right.
Okay, and I want 100 amps enough to get you going and get a pool, but you got to think aluminum dissipates heat quickly, so it saturates. So you'll probably be back out of this a little bit. And then no pulse or anything. And we've got, on this particular machine, we have AC balance, and you'll see it says % clean.
% clean.
Okay, so I want 30% cleaning action. What's that mean? Well, that means that it spends 30% of its time on the EP, or electrode positive cycle, and 70% of the time on the EN part. It's still alternating, but it's spending more time on that, 70% penetration, 30% cleaning. You're still gonna see what's happening, and you can kind of hear it too.
Well, what happens if you have it more than 30 or less than 30? Is 30 a range for you that you prefer?
30 is a good start here, because it's gonna maintain the integrity of your point on your electrode for now, and then we'll change this up. We'll make this machine go instantly it'll ball your tungsten.
Nice.
So right now I just want to keep this simple, and my whole concept of teaching is build the confidence, understanding, and then you can go through and play with all these different variables, just like anybody would with this machine, or any machine for that matter. So just want to get you started out.
Nice.
So welding amps at 100, We got 30% cleaning action. Frequency, okay? This machine will go from like 20, which is like real slow, and it'll go all the way up to like 250.
Max.
Frequency is the amount of time in this sine wave. See, normal and alternating current, like old time machines, like the sinker wave you were talking about,
correct.
60 cycles per second. And you can't change that.
Yeah.
And that's one of the reasons that your tungsten will ball.
Oh, okay.
You know, you've seen the old time Miller ABP 330s, the old round top, they call them gold stars. It's like a 800-pound box. I'm telling you, that power source was like sweet. And it was before the sinker wave came out. We're talking 1970s build, late 60s, early 70s build, back in those days.
I wasn't there.
I keep forgetting you're a youngster, man. Anyway, you know, great power source, but no, you know, we didn't have this control like we do with these inverters as far as cheating the sine wave or whatever. So frequency-wise, and we'll play with this, 250 sounds like a weed eater on steroids. It's real high pitch. So it's taking that sine wave, and instead of 60 cycles, it's now 250 cycles. So you can hear that.
Yeah.
And so I want to get this thing back down to, you know, 100 is just a good starting point.
Range. Okay.
Yeah. Because again, it'll kind of help maintain the integrity of your tungsten. As long as you're not dipping it like I do. Man, I'm getting good at that, dipping the tungsten thing. It's not funny. I don't know why you always got to laugh at me.
You know what? Because it happens the same with me.
It happens, yeah. And the last thing is the post flow. So now we're at a point, we got basic setup, we've got our argon on. I'm real certain that we're at 15 cubic feet per hour.
Sweet.
Thereabouts. We don't need a flood. You know, we just need a good blanket.
Nice.
Okay, so the next thing we need to go through is couple things about material prep. We mentioned that we had an oxide layer that we need to take care of. Your options when it comes to aluminum, you can machine it, you can chemically clean it, wipe it down with acetone, file, you know, anything mechanical. One of the best ways that I've found, and there's, you know, I'm gonna say there's a right and a wrong way. This is the best tool I've ever found. Multi-purpose tool, Weiler stainless brush. Great for cleaning the golf clubs. You know, when you hit them shots and take a divot out and you get that mud packed in there.
Yeah, it's not
clean
just for metal.
Yeah.
It's for other occasions.
So here's the, to me, this is the correct way. Watch this. You see this color and the sheen here.
Exactly.
Okay. So I'm gonna start doing this right here.
Instantly, you can see a difference already.
Then you get that black. See what I'm talking about?
First sight, when you see, you're thinking it's clean, you know.
Yeah, you think there's nothing on there,
there's nothing on there.
But you weld on it and you'll see it. When you know, you've seen aluminum welds where they have this white haze out around the weld. That's the oxide layer being broken up. Now, see, a lot of people will think, well, gee whiz, you're using a hand brush, why don't you just grab this guy right here and put it on a grinder and hog down and get it done real quick.
Is that the worst thing you can do?
This is a big no-no right here, because mechanically this is super high speed. This is soft. All you're doing is like impregnating this oxide layer back down into it. So a lot, you know, people with, and these Weiler products, I mean, you know, good stuff. Here we've got the flapper disc, super light pressure. You know, you can kind of clean and get this going. I still like this in the end. You know, again, you don't want to get into it and change the surface texture. You got to be careful on edges. So anything super light pressure, wiping it down with acetone. A lot of guys keep everything super clean. In your experience of aluminum, what have you seen? Like when you know it's dirty, you see anything floating in your weld pool?
Oh yeah,
like,
it's real black, like kind of
black pepper.
Black pepper. Yeah, exactly like that.
And so those are the oxides and the impurities that are coming off, and they're getting in your weld pool. And to me, in my experience,
doesn't look too pretty.
No, no. To me, in my experience with aluminum, it's like it's either good or bad. You know, I mean, when we're doing carbon steel and we're doing root pass on pipe, you know, you can kind of do some things and it'll clean itself out or clear itself or whatever. But man, you start out on aluminum and it either goes and you get a good pull, or it just kind of turns black and it's sitting there fluffing around. And it's talking to you. It's going, Hamar, I'm not going to let this happen for you right now.
Not today, brother. Not today.
Yeah. So I want to kind of scratch the surface here so you can run some beads. And then the other thing that happens is once you run one bead,
yes, sir,
and you're kind of heated up a little bit, you can, to me it's easier to clean again right next to the toe of the weld, so we run a series of beads. But again, you know, my hands were clean a minute ago, now I got this graphite looking stuff on there and it's getting worse. Let me borrow your shirt.
Yeah. How thick is this this metal that we're using right here?
This is like 11 gauge. 11 it's like 1/8 inch. And I want you to run a couple of beads with no filler wire, just to kind of get your hand-eye coordination, get your arc length.
Get it back, yes, sir.
And watch this arc. I want you to listen to it, and we can run a series of beads here. And there's another thing I need to talk about with aluminum. You said you did some spool gun work. Have you ever seen really nice looking aluminum welds, like on trailers and stuff?
I've seen a couple.
And you know, crack right down through the middle of it. Aluminum has this condition. It's like hot shortness. It's a metallurgical condition. It's weak when it's soft, so when you're welding, it's real easy with TIG welding to fill that crater up. But when you're using a spool gun and you terminate your weld, what do you end up with? You end up with that little crater thing, unless you can kind of do a technique where you come back and fill it in. You need that, because if you ever look closely at the termination of those welds, there's like a little star fissure looking eye thing in there.
Right. Yes,
guarantee you that little crack, when you put something on the road and it's in vibration and whatnot, that crack will propagate all the way down through a very beautiful weld, right down through the middle of it, and you're going, wow, you know, why?
Waste of time.
So that's just the nature of aluminum. We can probably create that. You don't be surprised if you see that, and then we'll show you how to take care of it when we're welding.
Yes, sir.
Okay? All right, let's run some beads.
Let's do it.
I know you like this super sharp point thing when we're doing a lot of, you know, like when we're doing our carbon or stainless or doing our piping and 100% root pin code quality stuff that we like to do, but I'm going to have to take you away from it.
That's
because this needle thing ain't going to work out so well. It's going to go away anyway. Hamar, we could do a big old long video on all the stuff that happens on alternating current, a lot of variables and variations and stuff. I just want to keep it simple. So I'm going to take and I'm going to take about half of your taper away from you.
Okay.
Okay. I'm going to show you how to purposely ball or blunt this. We can start out like this and we can purposely make it a ball, and it's all within machine settings. But just kind of trying to keep it simple here. I just want you to run some beads, but I'm going to take this away from you, so don't get mad at me. I'll give it back to you. We like this right here. It's a little more directed. We want to get this arc. Hold
it like a pencil, huh?
Yeah, I mean, I do however you're comfortable. Yes, but and we've got a flex neck torch on here, but it kind of helps out a little bit. You know, it depends on the joint configuration, but for running beads, I kind of like to get up here and, you know, be smooth. And then we're run a couple, terminate the weld, and then we'll get some filler wire going. Don't be surprised if you see a little bug hole.
It's all right.
We're not adding filler wire. I mean, you may pick up some surface stuff. I didn't super clean this, but I want you to see what's going to happen here. So
that's fine. Let's do it.
Nice, just like that, brother. Nice. I thought you said you needed help with this.
Like I said, it's been
pulling my leg, weren't you? Start coming out of it slightly. Now taper out. There you go. See what happened down here at the very end?
I didn't pull out.
Yeah. The heat's racing through this so much. Look at this, you get this little skin. That skin is where I never clean that. Have you ever seen a weld or seen somebody weld? You've probably done it yourself. I know I have. Trying to get a pool going on aluminum, nothing happens.
Yep.
And then all of a sudden it like falls out like solder. You know what's going on?
What's going on, brother?
Aluminum melts at like 1200 degrees. Depends on what it's alloyed with. Guess how hot the aluminum oxide layer melts at?
Hot, brother.
3700 degrees. So if you're not breaking it down, it's just sitting there like a skin. It's like you're melting the inside of an Oreo sandwich and it gets weak and falls away. It's got nothing there. So that's what that skin thing is all about. So you got this little haze right here, right next to it. So go ahead and run another bead right next to it. And then, you know, when like I say, about right down in here is when you need to start thinking about getting out of it. Now, when this coupon when this coupon gets superheated, we want to either go quench it and get the latent heat out of it, but about right down here, you can really start letting off, and your bead will stay the same width. Yeah, and you can kind of regulate that. But go ahead and do another one, and then we'll go to some filler wire.
Do it.
You came out of it pretty hard, but still nice. I mean, nice, straight, consistent bead, but you kind of see what's going on.
Most definitely, yeah.
Right here at the very end, it's not pronounced. You and I see it well, but it, you know, that's what I was talking about, that little slight crater thing, and we can make them. So now, let's go to some filler wire. We've got 1/16, 40-43.
40-43.
Get this where you're going to introduce this into the edge of the pool, like the front edge of the pool. And you've seen these guys on Instagram, Facebook, YouTube, and they've got some beautiful stacking dimes. Okay, how does that happen? You know, I want you to think, whatever the diameter of the electrode or the filler wire is, I want you to think about putting that much in. Does that make sense?
Yes, sir.
Because each time you add filler wire, you're like adding a cool mass. So you're putting that in there, and that's how you get that roll effect too.
Okay.
Aluminum will also kind of sink. You know, so there's a couple of things going on, but just keep it simple for now and dab some in there, and let's see where we're at.
Let's try
Then we can go into a couple of different joint configurations. You know, we're on alternating current. So you want to be fast and accurate. And you want to keep this thing in the shielding gas, because you know what happens, and I do it. If you're slow about introducing this into the pool, and you always want to kind of like put it in the leading edge of the pool.
If not, it'll ball up, huh?
Yeah, it's like the AC arc gets around this thing and it just wads it up, and it's like contamination. And you know, and the bad thing is, and I've done it, I think everybody's done it, you go ahead and like flip it off and then stick that into the well pool, and it cleans itself up. You know, I'm guilty of it. Do you like it?
Yeah, I mean, for the first time in 3 years.
Yeah, I wouldn't be disappointed with it.
3 years has been a
little wide. I was gonna say stab more wire, but I didn't say anything. I wanted you to go through with that roll.
Yeah.
I'm gonna go take the heat out of it, brush it down, and I kind of want you to make the same weld, except add just a skosh more wire.
More wire.
And just push. Think of the diameter. Push it in there just a little bit more, and I want you to see the difference in the weld profile. Okay, I cooled off your coupon and wire brushed it again. Man, when I wiped it down with the paper towel, there's a lot more black stuff come off of it. So, but the deal is, your bead is wonderful, don't get me wrong, but I want you to see if there's a different profile now that the material's clean, or cooled off and a little cleaner. You notice how there's a little pause, there's a little delay when you start. You know, start hot and then back off. Get your pull going and be fast and accurate with the wire, and then that maintains that width, and then you can kind of adjust travel speed. But you know, and you can hover a little bit. You just don't want to get, you don't want to get that black condition started or whatever.
Exactly.
Welded different, didn't it?
Started off
Got a little roundness.
Got a roundness,
little roundness
yeah.
to it, little height.
little height on it.
And then down here, when the coupon got saturated again, and to me it looked like you were still putting the same amount in. Maybe you put a little less, but still you can tell a big difference.
You can tell a big difference for
Okay,
sure.
so we can clean this off again or brush it and then run one right next to the toe of that weld. I hope I don't slip and run my elbow into your jaw there. All right, now run one. You can always, I mean, immediately you tell that color difference there, and you get that white haze that had that shine on there. So when they're hot, they kind of clean off better too.
Exactly.
Run one right next to it in the toe of the weld, and just kind of, and let's go just a little bit quicker.
A little bit quicker.
Stab a little wire.
Stab a
Just
little
go
wire.
with it.
A
Just
little bit
relax.
quicker, stab
Just
more
relax and go. Yeah. Heat it up a little bit. There you go. Stab it and go. Heat it up a little bit. You're at 83 amps, brother. Talk to me.
I feel like I did better on this one than I did this one right here, to be honest with you.
You didn't
This one's
feel good about the. What is your problem, man?
I have no clue, man.
So your hand-eye is like right there. You just need practice. You
just
need
practice,
time.
man.
You need hood
You know,
time. You know.
I'm not perfect by no means, and I say this in every video that I do.
I've heard you say that.
Yeah, I'm still learning
No,
every single day. Every single day.
I'm learning stuff every day.
And I think give me about a week and I'll be about 70-80%.
Some hood time, yeah. Let me in there for a second.
Yeah.
You're
Show me,
like
brother.
killing me, bro.
Get him.
Let's see what the old left-handed guy does here. I'm gonna run right down through the middle of that and show you what I'm talking about heating and going a little quicker.
Also, too, guys, I have to use a foot pedal, and when I did try the aluminum 3 years ago, it was with no foot pedal, just scratch and go. So
scratch on a sinker wave. You had a manual torch. You turned the gas on manually.
Yes,
I was gonna call BS on that.
yeah.
Huh? See, I know some things myself. You know.
Yeah. But
Yeah, that's odd.
Yeah.
That really kind of is odd to do aluminum that way. And breaking the arc is like you got to
like
get
that.
out of
Exactly. It was just one
So-
specific heat, and so me using a foot pedal, haven't used that in years as well. So still trying to get used to it. Like I said, by all means, I'm not perfect, but I'm still learning every single day. And Bob's about to run one for me.
it. Well, it ain't gonna be perfect, but I
want to see it.
I just want to show you the timing thing.
Yes,
Because
that's exactly.
we got to me it's too much variation.
Exactly.
Okay, that's all I'm saying.
Too much heat going on. Too much heat. I think it's more on my foot.
See the difference?
Big time.
Yeah, I hammered this. I started
You
100. I started at 100. I left it at 100, but
You're going fast.
I'm pushing enough, and that's that ripple effect in there.
Oh, okay, nice.
That's what I'm saying. And then when I get down here, you can probably hear it and see it on the video. I started like tapered out of this thing the whole time. I'm still pushing. That's why I don't have a depression in there.
Sweet, brother.
So,
Nice.
I mean, and it's so subtle. It's so subtle, but that's kind of like the nature of aluminum. Hot. Hammer this thing, get the pool going quick, get it going.
Exactly.
And then, you know, haul. You know, to me, when I was doing that, I'm going, God, that looks dirty under the hood, but it obviously looks better than what it looked like to me when I come up out of the hood here, but still, you know, the color. See, we've got this shiny, suspect looking color here, and then it goes back to a dull that we like, and then that's, you know, again, it's a little deceiving. It kind of looked funny, and you know, I'm not cleaning the wire, but anyway.
Well, let me try to give it one more shot. Since I've seen you do it one more time, I think I got a grasp right now. Let me see if I can get it.
Oh, gonna throw it down.
Let me see.
I'll show you one time. Now you got to show me up.
Yeah,
That's cool.
No, close.
You know, again, maybe the reason that this looked odd is because I'm going right over the top of that, into the toe of that previous weld. Not to say that your weld was contaminated or whatever, but you know, we can brush this off. You can run right down the middle of that. Just run the toe of the weld just like we stack stringers.
Exactly.
You know, that's the other good practice to do, is run right next to each other, and pretty nice ripple effect there.
Nice
kind of go right down through that valley there and see what happens, because this bead wasn't bad, you know.
It wasn't bad.
But
I think what I'm having trouble is I'm trying to keep them stacking dimes real tight. You know, I'm thinking that it needs to be real tight, and it doesn't need to be like that. Like your stacking pattern is really nice, and it's consistent.
Let me dress that quickly. Okay. I'm just going to go freshen it up just a bit, and then we're going to talk about tungsten grinds, the effects of, and we're going to go through some settings, and I want to show you some cool stuff that it'll help you appreciate what alternating current is doing, what the machine's doing, and you know, that way you can kind of understand. You go, oh, okay, I got this now. It's not that hard.
Exactly.
It just seems like a lot to it. That's all.
It does, but it's all good. We're learning.
All the way. There it is. Now taper out. So I'm talking about, I mean, just hammer on it and get it going, and that you'll know when you can back off.
Exactly. Yeah, that's better. Definitely felt a difference there. Way faster, more productive there
Now,
for sure.
It's obviously when these things get superheated, they just tend to weld completely different. But that one was barely warm because we cleaned up your bullet there and everything. So yeah, okay. So now we're going to do an outside corner joint.
All right.
And this thing is this is real easy. This is cool stuff here. You know, obviously we're rounding this up. We're catching both edges.
Yes,
the width is going to, you'll know immediately. There's a couple of variations of this. I've been doing this for like 30 years of teaching. Even though I was still teaching at night, and there's a couple of cool things that you can kind of fit up. One of them is a variation to this that leaves a little bit of a lip, and you're actually using the material as the filler wire. Does that make sense? And kind of get that melt thing going. And people do it right, and they're going, oh man, that is so cool, that's easy, and they get fired up, the light bulb comes on. But this one, you can do with and without, but I want you to do this with filler wire.
With filler wire.
So, and you're not, you don't have to push a lot, but this is pretty immediate success. Already got you clean, tacked up. So let's go ahead and fire and run this baby here. I went ahead and turned your machine down to 85 amps because I know you're not going to need all this. It'll help you out. Oh, what'd you do? Pull a bob there?
Yeah.
Oh, 2 of them. Oh, dang. What are you trying to weld like me?
I guess so. But when I got to here, I guess it stick to the tungsten and it pulled the material with it at the same time.
Mm-hmm. So, what do you think?
I mean, it came out good right here, and then until I stopped.
I think the middle of that is primo.
Mm-hmm.
I'm looking over your shoulder, and it was like that progression of keyhole,
Mm-hmm.
or like it wanted to open up, and that's what you don't want. You just kind of want it to flow flat.
That's
I also noticed it after, like down in here, you started putting that wire right on the edge.
Exactly.
You know who does that and does it extremely well?
Who?
Kane Kid. I stood here and watched him do it, and he's like feeding it right on the edge of the weld, and it was so cool. That guy
Sweet.
is like phenomenal.
Yeah, man, I think it came out good from here to here, and then obviously it touched and moved. But it is what it is, isn't it?
So, heat sensitive, outside corner joint, things are going to flow. And again, I told you I turned your machine down a little bit. What do you think is going to happen here? How are you going to, just thinking from common sense, how are you going to work this in there? Are you going to change your electrode angle? Which way are you going to put the wire in?
Well, I feel like if I'm going to put the wire, I'm going to keep it right in the middle side.
Okay.
Okay, and probably angle this. Well, no, I can keep this straight right here, right where the torch is at.
Good
right
thoughts.
Here. Yeah.
You don't want to force a bad
Yeah.
position. I mean,
Exactly.
we always have a little window that we can operate in. You got to know
I don't
what that
wanna be-
window is.
Exactly.
Common sense will tell you that.
And
But
I
I've
won't-
seen people push some extreme weird things, and it's like, again, this either happens or it doesn't, for me anyway. And I've seen people, they try to practice on this, and they're going, what am I doing wrong? And it could be something as simple as that right there.
Yeah.
You know what I'm
Just the
saying?
angle, just the
Just a
angle.
little bit of an angle
You get
because of the
frustrated. You get real
electron
frustrated,
emission and the
correct.
arc force and whatnot. So, all right, mate, give it a go.
Do it.
Not bad. Well, different though, didn't it?
Yeah, well,
I mean,
definitely different.
just from the nature of the joint configuration. Huh?
Exactly. But I mean, it's not horrible, but it's not. It could always be better, man. Always be better for sure.
Well, yeah, but you're getting
Yeah,
you're
I
getting
mean, yeah.
some background, some knowledge
Yeah,
of what
some
you can
knowledge.
practice on, and now
Exactly.
you kind of know what to look for and why.
Exactly.
So if we go with the fillet weld, the T-joint, how do you think that's going to react? Just from the geometry of, just from the nature of it, you got it, the confluence
Yeah,
of two
it's-
pieces.
I gotta focus more that rod towards the middle of the
Okay.
T-joint, because I don't want it to kind of like overlap or anything
Okay.
like that. I want it to fuse right in the middle of those T-joints. So I think
You're
probably
at
have to go a little bit faster
you're at 85. Do you
Yeah.
think that's enough?
for this.
Because personally, I don't. I think you need to go back up in amperage just to.
About what, 95, 100 again?
I'd go 100, 105.
Okay.
I'd rather, for me, I'd rather have it
Mm-hmm.
and regulate it and not need it than I would waiting on it to do its thing. Because I'm scared I wouldn't be able to hit that profile. Once I see that width and I want to maintain that, that's when I just kind of go.
Go.
I just kind of hit it and go.
Exactly.
Completely different. I mean, energy-wise, you got to do some stuff. I see you went up to 125 on the amperage. Decent profile. Hey, you got some stuff to practice on now. You kind of realize Hey, we're all green on certain things. I know there's stuff that I need to
Yes, sir.
practice on, and you got to step in and set some stuff up and go with it. So I want to challenge you to a couple of things, like real quick, and then we'll end this video. And I think we should probably do another one maybe on going through settings and understanding what's going on with the machines. Would that be helpful?
Yeah, for sure.
Okay, so let's trade places, and I'll show you a couple of things real quick, and we'll end this one up. Okay, when I said there's a couple things I wanted to challenge you with, all this material, all your little coupons, you know, we're running beads and stuff. Don't waste any of that stuff.
No, never.
You can go in there and stack welds and
Always.
stuff. Let them cool. Work on that bead profile. I think we had oh, this was our outside corner joint, wasn't it?
Yep.
So we go back in and put that fillet weld in. You know, obviously we need to crank it up a little bit. I'm still set where you were at 125. But now I'm obviously not going to use that, because what I'm wanting to do is kind of break this up, pinpoint this, get this precision thing weld on the edge. A little edge weld. We'll just start out, just run the bead for control, and then the last part of it we'll dab some filler in there. So
let's do it.
just watching that, just you know, I mean, we're just trying to get the melt, you know, obviously, and then we're going to do the same thing. We don't want to blow it up with width or anything. And when you get out here in the corner, what do you think is going to happen? You got to be real careful. So that's where we get that, we kind of dial in on that precision of terminating that weld without tearing it up. Good session.
Real good session.
Good session. I mean, you're
Learned a lot.
not far off. I can tell. I mean, you've done enough TIG work and stuff. You just kind of needed some background and you know what to go with here and work on.
Not an all natural aluminum welder, man.
Bead width and stuff like that.
Yeah.
You know, I mean, hey.
I had a great time. I had a
somebody,
great time, Bob.
Somebody that welds aluminum all the time, they're really, really good at it. Put them on a piece of pipe, have them do a stringer, and they, you know, they're not used to that. So everybody's got everybody's got their forte, you know. So.
Always. But I appreciate you, Bob. Thank you, man. And I learned a lot. And I'm definitely gonna go back to Houston, and I'm gonna practice, man. I'm gonna practice.
I'm gonna go home and practice golf, because I'm never gonna let you. I'm not gonna let you have me on the golf course. So I know you're gonna get real good at this. See, I still gotta have something I can hang in there with you on, huh?
You're bringing back Top Golf now, huh?
Hey, that was fun. That was fun. That's the first time I've ever been. Appreciate you watching Weld.com. Please subscribe to the channel. Subscribe to WeldTube. Telling you, this guy's got some great tutorials, got a lot of cool stuff going on. Check us out on Instagram and Facebook as well. Thanks for watching Weld.com. I'm Bob Moffett, Mr. Hamar Aguil.
Appreciate y'all. Thank you.